Hello and welcome back to another tutorial. This is my second tutorial on using BYOB to illustrate some algebra concepts. Today we're going to be graphing points, and so this is a very simple program where I take my sprite, in this case a little clam character, and he's going to move randomly around the screen and drop off 20 different points. I choose a random x coordinate, a random y coordinate, and he will go to that location. He'll take 1 second to get there, and then he'll drop a dot right there at that location. So this program can be used to help students learning concepts, reviewing concepts such as graphing points according to their x coordinate and y coordinate, determining how many points or when a point is in a particular quadrant or on the x-axis or y-axis. And these points are going to be chosen randomly. So I'll go ahead and begin a new file. And as I create this file, I'll go ahead and start by getting rid of this sprite. I'm going to choose a sprite from the file. I go into my sprite folder, and I'll choose, let's use Mr. Clam again. And notice that on the background I do not have the x and the y coordinate system. To get that, I'm going to click down here on the stage. And notice that the middle tab switches from costumes to backgrounds. If I go to background and say import, the clever people at BYOB put a nice XY coordinate system as one of my background choices. So clicking back on the clam, now I'm ready to go ahead and choose the scripts tab, and I'm ready to begin writing code. Going to control. I'm going to start the program when I hit the green flag, and what I'll do is something new. This time I'm going to create variables. So I click on the variable tab, and I click on the button that says make a variable. I'm going to call one variable x coord, and I'm going to call the second variable, make another variable, call this guy y coord. And remember, we can think about variables as simply places in memory. So right now, when BYOB creates these, they're listed over here. They also show up on my stage. If I unclick these boxes, they disappear. If I click these boxes on the side, the variables not only show up on the stage, but it tells you the contents. So the students can check and see what the contents is of each of these, which is going to be very nice for this particular program. Now, I'm going to go ahead and set my x coordinate and my y coordinate to specific values, and so notice that I have drop down menus here. I'm going to leave one x coordinate. When I click on the drop down menu, the two different variables that I've created, or any variables that I created, will show up in the drop down menu. So I'm going to choose y coordinate for the second. So I'm going to set the x coordinate and the y coordinate. Let's just leave them at 0, 0. And when I click on the green flag, my clam doesn't do anything because I didn't put a motion block in. Click on the blue motion blocks. I'm going to say glide to, and now what I need to do is go to the x location and the y location. The two numbers listed here where the clam actually is right now, but during the run of the program I'm going to go ahead and choose whatever's in my x coordinate and whatever in my y coordinate, in this case 0 and 0, and the clam is going to move or glide to that location. So here we go, click it on, and there he goes. He goes to 0, 0. If I change this number to, let's say, negative 180, and I change this guy to, I don't know, 200. Actually, y doesn't go down that far, does it? So make that 100. And if I click run again, he's going to go to that location. So whatever locations I put in here, the clam will move to that location. Now, I'm going to go back to control, and I'm going to put, instead of a forever loop, which I used last time, this time I'm going to put a repeat loop. And what I want to do in my repeat loop is I want to repeat this. Let's go ahead and leave it at 10. And if I repeated this 10 times, of course, I've only got one location here, so he would go to that same location 10 times. In other words, he wouldn't be moving. But I can change that. I can go to operators, which is the green set of buttons or blocks, and in this block I'm going to pick the random block, and I'm going to choose that twice. And so what the random block is going to do, it's going to give me a range of, it's going to give me a single random number within the range that I enter. So I'll enter negative 240 to positive 240 for my x coordinates. And what I'll do is I'll take this guy and I'll drop it right in here for my x-coord. And I'll do something similar down here for my y-coordinates. I'm going to go from negative 180 to positive 180. Now it doesn't matter which comes first, the positive or the negative, but I can see that my y-coordinate goes from negative 180 to positive 180, x goes from negative 240 to positive 240, and I'm going to choose random numbers within that range for both x and y. Now those are going to get located in here, and then I will glide to that location. Let's take 10 seconds to glide. Now again, my screen capture software is not going to show my clam moving, but when I run the program, he'll actually move 10 times to these 10 different locations. Let me pause it for a second right here and notice that you can check with your students, okay, we're going to the coordinates 208 on the x, negative 68. So that should be 208 is going to be somewhere over here on the x-axis. Negative 68 is going to be a little bit more than halfway down to negative 100. So he'll end up somewhere down here, and you can watch the clam move over there and even discuss it as he's moving. By changing the glide time to, let's say, 1 as he goes through, now he's going to be moving faster. I don't know if that's coming through on the screen capture software, but I'll go ahead and stop that now. He's not drawing anything yet, and so I'm going to make a couple of changes to this. I'll go over to pen, and what I'm going to do is when he glides to a new location, I'm going to say pen down, and then immediately I'm going to say pen up, and that will simply record a specific point. The other thing that I should do is change the pen size, because if I don't change the pen size, I'm just going to get one single pixel, which will be very hard to see. But if I change the pen size to 15, it'll have a radius, I believe, of 15, so it'll be a big enough dot to see. Also, I can change pen color, and pen color to whatever color I want, let's say pink. If I go ahead and run the program at this point, oh, I'm sorry, one more thing. Let's put in clear up here on top so it gets rid of any points from previous runs of this program. If I run this guy now, he's going to race around the screen, choose 10 random places, and he's going to put a dot right at that place. And every time he chooses a new location, he's going to take 1 second to get there. So that's it. If I run the program again, let's go ahead and take the clear block out for a minute. We'll change the color just so we can see. If I run the program again, I'll get new random dots, and you can see that they're in different locations. Okay, so I could have the students, for instance, tell me how many dots are in each quadrant. I can ask them to name a couple of dots and then find the coordinates of those dots or those graphs. And this basic program can go a long way to not only reteaching or ensuring that students understand how to graph according to coordinates, but we can use this as the base